So this is video lecture 10 on classes and objects. Here are the list of topics that we will be covering in this video. There's a lot of topics, so this may end up being a little longer. You have done from chapter 8 in the textbook in your CSE 15 an introduction to the concept of classes. And this is really the starting point of our object-oriented programming. The review that we did so far was about classes that have been provided by Java. In this video, we will review how we as programmers can create and use our own classes. So that's what we are going to stay with, and the topics are creating classes and as templates, using UML diagrams, which are basically customer-related specification documents, which may be given to us, which we may need to design, and from which we can create our classes. So the specifications come to us from the UML diagrams. And then we use these specifications to create class files. So create our class files right here. And once we dive into class files, we will look at special methods. One of the special method is a constructor, and some other methods like getters and setters, and a very ubiquitous method called the toString method, and also understand the concept of instance method. All of these now, constructors, getters and setters, toStrings, are all instance methods. They may be plus other methods which are typical of that particular class. But we will see how instance methods are a different concept from static methods that we've been using so far. All right, then we will go into a different file, which is the driver or the client program, which uses these classes and the types that we have defined with these templates to create objects. And then we will bump it up further to look at how to create an array of objects, how to create more complicated objects by assembling or composing a bigger object out of smaller objects. So basically this is a kind of a has-a relationship. I just would like to mention this because when we move on to inheritance in a couple of weeks, then we will look at other relationships between objects as an is-a relationship, not a has-a relationship. So the composition is a relationship between objects, which is a has-a relationship, and inheritance is a relationship between objects, which is an is-a relationship. And then we will look at professional documentation. So there are a lot of topics in this video, so let's get started with some concepts about classes. As you know, that in Java, because it's an object-oriented programming language, it allows us the ability to easily represent real-life objects. Real-life objects have certain characteristics like attributes. For example, a dog could be a certain breed, it has a certain color, and it has a certain age. So these are the physical attributes of the dog. And then the dog also has certain behaviors or actions. So a dog can grow, a dog can eat and bark and sleep and play. So all of these are the verb parts of the dog. The characteristics that we talked about can be considered as the adjectives or the descriptive part. So both these things together, they fully define a dog in the real world. Now this has to be represented in software and create this dog as a software entity. So in order to mimic that, again, the adjectives are the state, which is the set of values or internal data stored inside the object. So this is the equivalent, the state is equivalent to the age, the name of the dog, the breed, the color, and all of that. And the behavior is what can the dog do. So the first one is kind of what describes the dog in terms of attributes, and the second one is what can the dog do, and what are the actions. Now, of course, there's certain things that a programmer has to do. A dog can, for example, have certain behaviors, like, let's say, for example, a particular dog is able to make friends with only dogs of a certain breed. That might not be important for the customer. What may be important for the customer is maybe this is a company that does pet sitting. Maybe this is a company that just makes toy dogs. So depending on the company specifications, what the job of the programmer is to pick those attributes and pick those actions that the customer thinks are adequate to define the software entity or the software representation of the dog. And that's what is going to go into the class template. So the class template is going to be now a blueprint, and this will now end up being a dog class, which gives the state and the behaviors, right? So that this can be used as a template by the program to create software dogs. So that's what we're trying to do. And the client is the code that uses the object. So moving on. So each class then has got to clearly, in terms of, now these are data stored inside the object. So what is this data going to look like? This data inside could be something like integer for age, could be string for color of the dog, and so on. So these are your regular now inside the dog class. You can have this information, which is the state or the attributes. And then you can have the actions that the dog does. So now these are your public, let's say bark, public void bark, and so on. So note that one word that we've been using a lot here, static, is missing. And that's not going to come inside a class. The reason for that is that static means there's only one method of that name. And what we are saying is that we would like to have the flexibility to use this template to create many, many, many dogs. And each dog needs to have the ability to bark. We're not going to give different method names for each dog, but each dog, when we say dog bark, it's going to be able to bark. And that's why we need to have multiple instances, if you will. So this dog 1 is also going to have bark method, and dog 2 is also going to have bark method. They're going to have multiple copies, different copies in different areas of memory of this method, but the name of the method is going to be the same. And that's why these methods are called instance methods, because they're instantiated whenever we create a dog. But static is totally opposite. Static means you have a main method and then a main program, and then you have got a main method, which is also static. There's only one of that. And then you have methods, and there's only one of that. You don't create copies of methods inside your main client program. So now here's the thing to note is each class is stored in a separate file, and you can also store them in the same file, but it's good practice to store them in separate files so that they can be compiled separately. And it's great software engineering stuff, because if you have a large project, then, and if this is a company that's trying to create a toy zoo, then, you know, one programmer will be working on a dog and another on an aardvark and another on a shark and so on. So each one is responsible for their own class, which they can write, which they can compile and test. And then everything gets pulled together to make the zoo program, right? So how is the customer going to talk to the programmer to say what they exactly mean when they say they want a dog? So here is what is called a unified modeling language. This is important because the customer may not necessarily know Java. So this is a language independent communication document which the customer is going to give to the programmer and say, what I'd like here are the attributes. These are name, age, and color is sufficient for me. And then here are the methods that the dog should do. Now we will dive in a little bit into detail, and I think you already might have done in your CSE 15 class, is what are the specifics of this, but we will go into this just briefly for now, and this is the constructor. The UML diagram can also have more detail. This is the constructor, and I'm going to call this a default constructor because it has no parameters. This is like saying, can you give me a dog method? And so that when the dog gets created, everything here is set to blank, is set to a default value. All of these attributes are set to a default value. That gives us an indication that what the constructor method does is when we create a dog, this is the method that gets called so that certain values can be saved inside these variables. So when we create a dog in our main program, then according to this, it's got name, 3 boxes. This is the name, and this is the age, and this is the color. So then when you say dog D is equal to new dog, then what's going to happen here is that this constructor is going to get called. When you say new, that's when this method gets called. Now, if you call the default constructor, it's going to set to certain values. And let's presume that the values are just age is 0 and name is blank and color is blank. That's what's going to happen. It's the factory dog that gets produced is going to have these factory settings. However, this is the regular constructor, this one. Here is where you can actually pass information and say, can you please create a dog which has got a color black and age is 5 and name is Bodhi or Bobby. And then when this constructor is called, this is what is going to go into these boxes here inside the memory. It's going to be Bobby, age is 5 here, and color is black. So this is how constructors are used to fill the values inside these attributes inside the memory of the computer. Now we need a way, if this is a dog and a dog is a software object, it's got to interact with the outside world. A real dog is going to move around, bark, and do all of that. But let's say an electronic dog or a software dog is going to need to have some way for the user to interact with it. And these are the getters and setters that can interact with the dog. Now note that get age, get name, get color. One for each, name, age, color. So there's a getter and there's a setter for each of this. And as you recall, a getter just displays the information. Getters are for displaying information, and setters are for changing information or updating information. So it's as though there are going to be 3 buttons here, 3 buttons here. These are the getter buttons, and these are the setter buttons. And so this get age is like somebody pushing this button here and saying, can you show me your age? And then there's going to be a little display here where the name Bobby is going to be flashed on the screen for the customer to see. So this is, basically a representation of the dog. And if you want to change the name of the dog, we press this button and say, can you change your name to Duff, for example, right? And then this goes and changes. Instead of Bobby, now you've got Duff, right? So this is how the getters and setters work, and the customer is aware that these are the capabilities, and these are the capabilities I want. Now, in addition to this, there could be other methods too. And the one method that is going to keep popping up is the toString method. ToString method is a method that returns a string, a software representation of the object, or a string representation, more precisely, string representation. So when you say, can you do, for example, d.toString, then what we expect to get is a string that could be something like my name is whatever name it is, my age is so-and-so, and my color is so-and-so. So this is a very basic method that's available whether you write or not. Java will try to give some kind of default, but it's good for us to write our own toString method so that if we want to print the object, then we know that we have a way to extract information from inside the object and display it for the user. Now, the toString method in this case just returns a string, but for example, it could return an image, it could return a picture of a dog, it could return sound recordings of its barkings, it could do a whole bunch of stuff, right? There's one last thing that on this slide that I wanted to point out is this negative sign here. This means that something is private, and the plus means something is public. This is a huge one, and this is a very big concept in object-oriented programming, is that the internal information of the dog, and it could be anything. For example, it could be a student and it could be the social security information. This is something that is private and not visible on this software entity. And it is guarded. And that's why you have these getters and setters, because getters and setters are public. That means anyone can push the button, but no one can actually go inside the dog to get its social security information or its name and change things and have software leaks or security leaks. So this is an important concept, and we will just talk about this in a little bit. So this brings us to the concept of abstraction and encapsulation. These are two key features which are core object-oriented programming. Let's talk about abstraction. What abstraction is, for example, with a dog, we do not necessarily, as customers, would like to involve ourselves in the internal mechanics of how does the dog grow, how does the dog eat, how does the dog actually, sleep. What we are interested in is we're just interested in interfacing with the dog. Now, another example is, for example, a car. We are not interested with the inner workings of the engine or how the wires are connected. For us as customers and users of the car, all we need to know is how can I drive this car, and how can I use the steering wheel and the accelerator and brake, how can I turn the engine on, how can I get information about what's the status of the car, i.e. what's the mileage, what speed is it going at, how much gas is there, how can I actually fill the gas tank, and so on and so forth. But we are not concerned with what's really happening under the hood. And that concept is called abstraction. So the ability to hide the inner details of an entity that we're trying to represent, a real-world entity that we're trying to represent as a software object, we are not concerned about the inner workings. All we want is to provide interfaces to the user so that the user can use it. And these interfaces have to be very friendly and easy for the user to use, and to be able to maintain the privacy and manage the external behavior of the dog. For example, if the dog is barking, then we probably need to want a button which says stop barking, right? If you want the dog to play, we want it to start playing, and then we'd like it to stop playing. So we are not concerned about the digestive process of the dog. So this is called abstraction. Encapsulation is related to this. Encapsulation is about hiding the details, and it enables the abstraction. One of the big features of object-oriented programming is that if you have this kind of facility, then when you have a class, then what typically happens is that this software here is just like a secret recipe. The customer does not get the code for the class. The customer gets maybe a compiled version that they can run. For example, if you purchase an app, you don't typically get the code of the app. What you get is you get to download the app and you get to run it. Exactly in the same way, when you write a class, then you get the runnable version of this class, so that you can create as many copies of this object as you want on your site, or your programmers can do it. But the person you purchase this class from is not obliged to send you, depending on the contract, of the code. Why does that happen? It happens because, for example, companies like Apple or Android or whatever you may have noticed are constantly changing. They are constantly changing the inner code. And software updates keep happening. Sometimes we're not even aware. The updates happen overnight and we're not even aware. And nothing changes as far as our usability of the phone or whatever it is, a software that we're using. This is a core feature, and encapsulation allows us exactly that. It allows us to help with software maintenance and upgrades. Why do I say that? This means that the person who's writing the class can actually go and change how the method is written, maybe write things in a more efficient way that saves time, that saves space. But when it runs, the user has no knowledge that the backend has gotten changed in some way. It's just the front end that the user is concerned with, right? And doing encapsulation and hiding information and keeping information private also helps to keep the data secure, because we don't want somebody accessing our social security information or our address or other bank balance and private information. So in a nutshell, classes are a software engineering approach to programming. And once we have these units, then we can actually represent many things in the real world. So let's say, for example, in a school is an object. Then there are instructors who are objects, students are objects. The learning management system is an object. So as you can see, abstract things and living things can both be represented as software entities, and then we will find a way for these objects just in real life to interact with each other. Objects can also interact with each other. For example, students talk to instructors, instructors talk to the department chair, for example. So these objects communicate with each other. Another interesting thing is that when you look at a department building, then the department building is an object. And that building consists of rooms. And then those rooms have tables. So when we assemble a table, an instructor, let's say a chair, a computer, a door, then that becomes a room. And then when we assemble a lot of rooms and corridors and this and that and the other and stairways and elevators and all of that, that becomes a building. So you can create bigger objects out of smaller objects, and that is called composition, and we will come to this in this video in a little bit. So, but first, before we do anything, we would actually like to take a look at a simple class where we are trying to create this dog. So first we will look at the class file, and then we will. So here is our dog that we've been talking about. And we've kept the name, the age, and the color private. Note these are simple primitive types: string, integer, and string. This is what our constructor is going to look like. What our constructor is doing is it's assigning default values to these member variables that we have declared here. There's the default constructor. It actually allows the user to specify or customize the dog. And so the name, age, and color can be specified by the customer, and then we assign the incoming age to this age, name to this name, and color to this color. So what is the meaning of this? This is just a reference to the variables inside the class. And the reason why we need to use the prefix this is because if you can see, the incoming parameter name is the exact same as the member variable name. And then if we do something like, can you do age is equal to age, then this is a very confusing thing, which age equals to which age. So we say that, can you set this object's age to the age that the customer is specifying? And that's what this means. So, and here are the getters. What the getter does is a method. It kind of is like someone's pressing the button on the dog, and then the dog is supposed to display or get its information and show it to the customer. So this returns the name, returns color, and returns age. Set is something that changes. So it takes a parameter and says, you want me to change, but change it to what? So it takes the income and age from the customer and then sets this age. The toString, this dog has some additional methods called a sound. So the dog can make a sound, or the dog can bark, and so it returns bow wow. And here's the famous toString method. I'm a dog, my name is, add the name, add the age, and add, and then you could have added the color, but here the sound is getting added. Here's an important note here that ideally there should be no print statements, And rather what you should be doing in the class is that you should be giving the software or the string representation of the dog. And because a class has to be as independent as possible, and typically the programmer who writes the class has no idea what printer or what availability is there for display. So a simple string display is done, and then it's up to the customer to do what they want. And the class should typically throw exceptions if something really bad happens, and we've gone over exceptions already. So let's look into the main program here. And here is the class template that we just looked at. And now I'm using this type that I have created called dog, just as I would do integer x. I'm using dog buddy, right? And then I'm saying, I could have just done dog buddy. If I do dog buddy, then you just declare a variable of type buddy. But the memory for this dog is given to us when we say new, and then the constructor is called, the default constructor in this case, to set the internal member variable value. So now we've completely constructed the dog. We print the dog, change the dog's age, right? And then we print the age, change the dog's age, print the string representation of the dog, create the second dog, and so on and so forth. So let's just run this program and see that it all works. So here we've got Buddy's age is 0. Now I'm 77 years old and I make a sound bow wow. And here's I'm a dog, my name is Cody, and I make a sound bow wow. So all of this seems to be working, and you may have noticed that it says Buddy's age is 0, and here it says I am a dog, my name is blank. Well, my name is blank because we didn't set the name here. We just gave it a default name, and then in the default constructor and only changed its age. Whereas with Cody, we used a regular constructor and passed the name, age, and the color of the dog. Now, so this is called the driver, or the client program or driver. It's used to create objects, create and use objects, right? So we've created the object and we've used it by calling the methods. And this is the way to call the methods. As you know, we've used this kind of method calling process with string, and we've used it for all the classes that we have reviewed so far that were given to us by Java. And when we create our own class, this is no different. We can use the dot notation to call the methods that we have created or the customer has asked us to write. So this is the class file, and this is the driver file. And you may be asked to write just classes. You may be asked to write a class and then create objects. And all of this is going to be done in your labs and your assignments and in your exams. So let's move on to the next topic here. Here are some of, now moving on to a little more advanced features. Objects can be passed as parameters to static methods. Objects can be returned from static methods. So now we're bumping the whole game up. You're saying not only can we create objects, but just as we pass integers and arrays into methods and have them as return values, we can do the exact same thing for objects as well. Because after all, the objects are nothing but references or pointers to memory locations, right? So we can do that as well. And we can create arrays of objects, and we will see how that can be done. So let us look at some of these features, and then we'll go into object composition. So this is an example of how we can pass objects as parameters and return objects from objects as return values. So let's now look at this dog class. Now it looks like the same class, except that I have added a method here called bigger than. Now, this is going to be a concept that may seem a little weird, that inside the dog class, we have a method that's taking in a dog as a parameter. So this dog is now talking to the other dog, and that's why I've called this other. And what's happening here is this dog is comparing its age to other's age. Now, how can this dog get the other dog name? It can do it by pressing the get age button of the other dog, and that's what we're doing here, saying other.getAge. And then compare the two ages, and if this dog's age, you can say this dot age to make the difference between this current object and this dog and the dog that it's talking to. And if this age is greater than the other age, then you're going to return true, otherwise you're going to return false. So this is how you can pass an object or a dog as a parameter. Now here is how you return a dog from a method call. This one is going to clone its own self. Think about this. What we're saying is inside the dog class, we have a method called duplicate, and what it's doing is it's creating a dog and giving the same age, name, color as your own self. That is, you're cloning yourself. And now you're returning the clone that you have created of yourself. And this is not a strange thing, you know. Dogs give birth to puppies, right? And passing on the same genetic material and all of that. So this is something like that. Now let us look into our main program and see. You've got one dog called Linda, the other one is Frodo. We print that, and then we're trying to compare Frodo with Linda. The basis for the comparison is the age, right? So if Frodo's age is greater than Linda's age, then Frodo is going to be bigger. And if otherwise, you know, this is Linda's going to be. Now here, we're going to clone Linda and then say this is Linda's clone. So in order for us to be very clear, let's look at the ages here. Linda is 5 and Frodo is 2. So if we compare Frodo with Linda, and Frodo is 2 and Linda is 5, then Linda should be bigger, and that's what we should see. And then Linda is a dog which is 5 years old, name is Linda and golden. If we clone her, then that is what we should get. So let's run this program. So now it looks like we have, let's run this program and see. You see, I'm a dog, I'm Linda, 5 years old, my name is Frodo, and we can see that Linda is bigger because Linda is 5 and Frodo is 2, and Linda's clone is the same as Linda. So now we have got the concept of passing a dog as a parameter. How did we do that? We said Frodo, call Frodo's bigger than method and pass Linda to it. So we passed Linda as a parameter, and she's a dog. And here we said create a dog object called clone and Linda.duplicate, right? When we call the duplicate method on Linda, she's going to return a clone of herself, and that's what's going to get saved in clone, and that's what we printed. So these are powerful concepts, and I would encourage you to practice them. Now, the third thing that we wanted to do was we wanted to look at arrays of objects. Let's do that. All right, so now what I'd like to do is I'd like to create an array of these dogs. We can do that exactly the same way as we create a regular array. So now dog, close, open, close is equal to, I'm trying to create 2 dogs. Now what I'd like to do is I'd like to leave this as it is, and run this, and you will see something strange and startling. So now we see something strange and startling happening. We tried to print and we got null pointer exception. So this seems a little weird because we created the array here and now we're trying to print it. Know that creating the array, what it does is it just gives to us array of 2 dogs here. So this is 0 and 1, and this is our dog array. And it has given us memory locations, a pointer to this, and there is 2 elements in this. This is dog 0, and this is dog 1. But what's inside here is null. This stuff has not gotten initialized or constructed, so the dogs here do not exist inside. They have not been constructed. So we need to first go and do that. And so what I'm going to do now, I'm going to say, now can you initialize the 0th element of the dog array to be equal to Linda, who's already an existing dog here, and I can assign the address of Linda to dog array 0. And here what I'm doing is I can now also, I'm just trying to show you that you can initialize this way also, is equal to new dog and then pass the age 6 Amy and Golden. So now I've got in my first box, I've got Linda, a pointer to Linda. Here I've got a pointer to a new dog called Amy. And now when I run this, I've got, I'm absolutely fine. It says I'm a dog, my name is Linda, and the last line says my name is Amy, I'm 6 years old. So, so this is how you can create arrays of objects, and be careful about initializing, otherwise you may end up getting a null pointer exception. I'm going to stop this video here, and we will take up object composition and Java docs in the next video.